In physics, we have two kinds of measured quantities. Some things are called vectors, and some things are scalar quantities. So let's see if we can figure out what the difference between these two quantities is, and then we'll look at how we work with them. So suppose you want to give somebody directions on how to go to a specific place. You might tell them, walk 5 meters north. Or suppose you were trying to get somebody to move a box and you wanted the box to end up someplace special. You might say pull with 12 newtons of force to the left. Now let's compare those ideas to other kinds of things we might measure. For example, suppose something takes 25.4 seconds to happen. Or suppose we use a balance and the mass of what we put on the balance is 1.23 kilograms. These are four examples of measured quantities that we might talk about in physics, and I've grouped them together. And so the question is, what do the two things that I've labeled as vector have in common, and how are they different from the things that I labeled as scalar? All right, you might notice that the vector quantities, in addition to giving us a number and a unit of measure, also have a direction, like north or left. Or we could say, go up. Up would be a direction. So it looks like the thing that makes vectors different is the direction. If we look at the two numbers that are listed as scalars, there's just a number and a unit. There's no up, down, east, west, north, south. It wouldn't make sense to say 25.4 seconds north or 1.23 kilograms to the left. So that's the key difference. If something is a vector quantity, it has a number and a direction. And if something is a scalar quantity, it's only a number. Scalar quantities are things that you've been working with all your life. If I run the first lap around the track in 15 seconds, and I run the second lap around the track in 10 seconds, then the time it took me to run both laps around the track is going to be 15 plus 10 is 25 seconds. If my cup that I'm putting my water in has a mass of 20 grams, and I put in 45 grams worth of water, then the mass of the cup plus the water is going to be 65 grams. So scalars are ordinary numbers, and we add them and subtract them the way we've always added and subtracted numbers. But vectors, because they have direction, have some special rules. So let's explore how we work with vectors a little bit more. Okay? There are two aspects to the vector. There's the number part and the direction part. A little bit of vocabulary here. The number associated with a vector is called the magnitude of the vector. And it doesn't matter what kind of vector it is. The size of the vector is the magnitude. So 25.4 meters north has a magnitude of 25.4 meters. 11 newtons to the left has a magnitude of 11 newtons. Okay? Now, in addition to the number, we specify the direction. And when we draw vectors, and we are going to draw them, to show the direction of the vector, we draw them as arrows. Okay? So a vector is an arrow on the paper that has a length and a direction. Here's an example. All right, this vector points to the right, and the length of the vector is what we call its magnitude. Now, how do we add vectors? All right, suppose I have a vector force that pulls 5 newtons to the right. All right, suppose you have a vector force that can pull 10 newtons to the right. What happens if we combine our two forces together? Well, it might be obvious in this case that if I pull with 5 newtons to the right and you pull with 10 newtons to the right, we're probably going to end up with 15 newtons to the right. But what I want to show you here is how you do this symbolically in how we do this when vectors aren't in the same direction. So we want to have some rules. All right, there's two parts to the vector. There's the tail, where it starts, and the tip, where the arrow is. Whenever I want to add vectors, and it doesn't matter what the vectors look like, if I want to add the two vectors, I have to connect them tip to tail. So if I want to add our two vectors, I'm going to take my 5 newtons and add your 10 newtons to it. So I take your 10 newton vector that I drew and I move it so that it's right at the end of my 5 newtons, connected tip to tail. Now, to find out the length of my new vector, the magnitude of the sum of these two vectors, I'm going to draw a vector that goes all the way from where the first vector started, back here, to where the last vector ended, up here. Here's what it looks like. And then I look and I ask, what is the magnitude or length of that vector? And hopefully it's obvious in this picture that the length of that vector is 15 newtons. So my 5 Newton force plus your 10 Newton force, when we both pull in the same direction, gives us a total or a result of 15 newtons. We're going to hear that word a lot, result. The sum of two vectors is often called the resultant vector. Okay? The sum is called the resultant vector. So we'll have to keep that in mind as we go along. Okay, let's look at a different scenario. We're going to work with the same two vectors, but we're going to make them somehow different. All right, so again, here's the 5 newtons, but now I'm pulling to the left. Here's the 10 newtons pulling to the right. How do I add these two vectors? All right, remember the rule was I want to connect them tip to tail. So let's start with your 10 newton vector to the right first. And to that vector, I want to add my 5 newtons to the left. So I take my 5 newton vector that I've drawn, and I move it to the tip of your vector, and I connect them tip to tail. The tip of your vector is touching the tail of my vector. Now, as before, to find the resultant vector, the sum of these two vectors, I want to draw a vector that goes from the starting point to the ending point, and here it is. All right, so this vector, this red vector here, shows us the resultant vector, and it looks like if I go 10 to the right and come 5 back to the left, that I end up with a net of 5 newtons to the right. So in this case, the resultant force would be 5 newtons to the right. If we think about it as a tug of war, if you pull with 10 newtons to the right and I pull with 5 newtons to the left, you're going to win because yours is bigger, and you're going to win by 5 because it's 5 bigger than mine. This 5 newtons right here, this resultant, shows that your force to the right is 5 newtons bigger than my force to the left. So again, when we add vectors, we draw them tip to tail, and then to find the resultant sum, we go from where our first vector started to where our last vector ended. So far, so good. But there are other possibilities, so let's look at one more. Suppose this time you pull with 10 newtons to the right, and I pull with 5 newtons towards the top of the page. Okay? What's the rule? To add these two vectors, what do I have to do? That's right. Even though they aren't on the same line, we can still follow the rule we said, which is when we add vectors, we draw them tip to tail. So your 10 newton vector plus my 5 newton vector drawn tip to tail. Again, the tip of yours connects to the tail of mine. All right, now to find my resultant vector, I go back to where I started, where your 10 newtons started, and I draw a vector that goes to where my 5 newtons ended. Here it is. Okay. Now, how are we going to find the length of this vector? This is not something that we can just say 10 plus 5 because, well, it's not. You might recognize the shape of this figure, though. It's a triangle, and it's not just any triangle. It's a right triangle. And so we can take advantage of the rules of right triangles to find the length, the resultant of the sum of those two vectors. Now you might recognize the resultant red vector in this picture is the hypotenuse of the right triangle. And you might remember that there's a theorem in geometry that tells us how to find the length of the hypotenuse if we know the two sides. It's called the Pythagorean theorem. And it says if we want to find the hypotenuse, we do hypotenuse squared equals one side squared plus the other side squared. So in this triangle, that means 10 squared plus 5 squared has to equal r squared. So we square 10 and we get 100. We square 5 and we get 25. We add them together and r squared equals 125. So r is going to equal the square root of 125, which is 11.18, but we want to round that up a little bit, so we're going to call it 11.2 newtons. Okay? So the working with vectors portion of this little segment, the key thing to remember, always draw vectors tip to tail when you want to add them. Once you've drawn them tip to tail, then draw your resultant vector. If they're on the same line, it's easy to figure out how long the resultant vector is. If they form a right triangle, it's still easy to figure out how long the resultant vector is. Enjoy your work.